Hello and welcome to this presentation of People on the Project, presented by Tech Training LLC. In this presentation, we are going to identify the professionals in a construction project, including architects, engineers, tradespeople, support staff, material suppliers, and equipment suppliers. We will discuss their roles and responsibilities on the construction project. We'll finish the presentation by touching upon some great leaders and their approach to completing great construction projects. The product of a construction project may exist for hundreds of years. People occupy the buildings, maintain the refineries, operate the pipelines, and use the bridges. However, no one interacts quite as personally with these projects as those who design them, dream them, or build them. Construction projects are born from ideas, designed by visionaries, and built through skill, and yes, blood, sweat, and tears. These are the people on the project. For an idea to be realized, it must be translated into graphic form, which in turn must be transformed into a finished product. The idea is defined by the owner, developed by the designer, built by the constructor, who then turns it over to the owner. Who fills the role of owner, designer, and builder, and how they relate to each other are determined by many factors, including time, money, project, and culture. At first, these roles may seem simple to define. The owner is the one who pays for everything, the designer designs, and the constructor builds. However, it is simply not that easy. In fact, these relationships are extremely important. They can make or break any project. Owners are often large organizations or institutions that are responsible to a board of trustees or a foundation that demands tight fiscal control. Designers depend increasingly on manufacturers, suppliers, and builders for technical expertise as technology and product design become more sophisticated. Constructors are professionals with advanced technical degrees who manage projects with sophistication and advanced project delivery methods. Consider for a moment the organizational chart and the responsibilities of these projects, and you will see how these relationships become even more complex. Owners' increased need for tight financial control and quick project turnaround, coupled with concerns about the rising cost of litigation, are contributing to a change in the way these roles relate. So let's take a look at and try to break down each of these participants, and let's begin with the dreamers. These are the people who see a road where one never existed, a new ballpark, or a home to raise a family. Let's start with the owner. Owners can be individuals seeking a home for growing family, a large organization responding to a change in technology, a municipality seeking to improve its infrastructure, or a developer working to make money by filling a perceived market. The motivation to build is as varied as the profile of the individuals and companies seeking to build. Whatever the motivation, the owner is where the project is formed. After identifying the need, the owner's most important function is to financially back the project. Otherwise, there can be no project. The source of that financing partly defines the type of participants on the project. Over 1/4 of the construction in the United States is done with public money. That money can be from local, state, or federal sources, but in all cases, the owner is the taxpayer. Because these agencies represent the public, they must follow specific methods of managing the project. Public approval processes have to be figured into any schedule or budget. Designer and constructor selection processes are carefully spelled out. Negotiation of claims is well defined, as well as the payment of all invoices. There are special pressures on the team that is designing and building publicly funded projects. During design, there can be multiple reviews by various agencies. Federal or state regulations that are not part of local building codes can be enforced. Bidding requirements may affect how specific building constructors are selected. Reporting requirements can be expensive. The owner's representative must be well versed in all of these special requirements. to ensure that public money is well spent and that documentation supporting all actions is maintained. Most construction is financed through private ownership. This category includes both the homeowner who builds only one house in a lifetime and the multinational company that owns numerous facilities around the world. A developer is a special type of private owner who often owns the project only for the duration of construction. The developer looks for an economic opportunity and puts together a package that includes marketing, financing, location, and image. The goal is to make money, either through selling the facility or units upon completion or through long-term rentals. Changing technologies, market competition, management innovations, organizational growth, and the natural aging of facilities are all factors that create the need for projects. A building committee is another form of owner representation, consisting of users, financial backers, and sometimes community residents. Building committees reflect the prominent place of the design and building process in the business of some organizations. User representation is especially important because, as technology and production processes become more sophisticated, the link between the new facility and the use becomes more critical. In all cases, whether represented by a facilities manager, an outside consultant, or an ad hoc organization formed for the duration of the project, owners are primarily concerned about their needs and their money. This concern is translated into a scope of work and a budget, which together with a timeline become the guideposts of the project. Owners represent a specific interest during the project's life. While designers focus on functionality, aesthetics, and innovative use of materials, owners are concerned about the durability of the design, storage and availability of materials, simplicity of operation, and ease of maintenance. Constructors are concerned with maintaining the schedule and budget through efficient methods of assembly and improved management techniques. Owners are additionally concerned about a turnover process that ensures a complete understanding of all systems in the new facility and a smooth startup transition. This focus can put them at odds with other members of the project team who are very narrowly focused on the design and construction. In the best of teams, these diverging interests form a creative tension that encourages all members of the team to incorporate the interests of the owners as their own. Architects and engineers are the principal designers of construction projects. On most building and residential sector projects, the architect is the lead designer, laying out the concept on paper with the owner. The engineer is usually brought in after the basic concept is worked out, but before the details are developed. The engineer designs the building systems, structures, as well as mechanical, electrical, and plumbing systems. On infrastructure and industrial projects, the lead designer is usually the engineer. The architect is brought in to work on the aesthetics. As an example, on a refinery project, the engineer designs the mechanical, electrical, and structural systems, while the architect handles the office spaces and the building color schemes. Each professional contributes to projects in different ways. When architects are given a design challenge, they respond by first identifying the important elements of the design. For some architects, the physical context is the guiding feature. Others are guided by the activities that will occur in the building, and others still will focus on creating a unique image. Very good architecture responds to all three aspects. The process is intuitive and subjective. Architects become known for personal styles they developed over the course of their careers. Some architects tie their work to historic styles. Others are more modern in their expression. They are hired to express those particular responses. An engineer's approach to design is much different from that of an architect. Engineers tackle a challenge objectively, breaking it down into identifiable components and a series of questions to be answered. When engineers are the lead designers, the functional aspect of the work takes center stage. As an example, in the English Channel project, image was less important than the safe, efficient boring of many miles of tunnel. the removal of soil, and the insertion of the tunnel liner. Architects end up being the stars of the building industry, and many famous architects easily can be named: Frank Lloyd Wright, Norman Foster, Frank Gehry, I.M. Pei. The profession has a certain mystique about it, romantic, artistic, and not entirely understood by people outside the field. Architects are the industry's image makers. Traditionally, they have also been the primary representatives of owners' interests. Because owners usually hire architects first, they are the first people to hear the owners talk about their needs, and they are the ones who meet with the occupants and help define the budget and the schedule. Often they influence the choice of contractor and delivery methods and act as an owner's representative throughout the construction phase of the project. An architect's responsibilities are to translate and develop an owner's requirements and graphically represent them so that the contractor can accurately price, schedule, and deliver the project. That responsibility is complex. In addition to understanding the requirements of the owner, the architect must have enough skill and expertise to choose appropriate systems and materials, and the talent to formulate a design that is mathematically proportioned and aesthetically pleasing. Architects learn their trade through many years of training. There are bachelor's, master's, and even PhD programs. There is also a number of years a young architect must apprentice before they can take the architectural exam. The architectural exam requires an individual to show competency in many areas of construction, including programming, planning, and practice, site planning and design, building design and constructions, schematic design, structural systems, building systems, and construction documents and services. The field offers many opportunities. Architects can choose to practice as part of a large firm, a small partnership, or independently. They can specialize in one building type, as an example, residence, healthcare facilities, universities, sports and recreation facilities, or museums. The list is extensive. In addition to practicing architecture, licensed architects have other alternatives, working in other fields such as owners' organizations, government agencies, teaching, marketing, and sales. Architects are usually the principal designers on building projects, but many other professionals contribute to their work, including specification writers, computer-aided design operators, interior designers, and landscape architects. These specialized professions developed as the tasks facing architects became more and more complex. Sometimes, especially in larger firms, those professionals are employed full-time by architectural firms. In other cases, they work independently and brought in as consultants as needed. In addition, these professionals can have their own independent practices and can be brought in by clients to work directly as principal consultant. When brought in as a consultant, an architect may be hired for any one of the following positions: lead architect, draft person, BIM operator, specification writer, interior designer, and landscape architect. Therefore, it is obvious that being an architect can lead to many roles within the construction environment. Now let's take a look at engineers. Anywhere from 25 to 65% of construction costs may go to engineered systems. Therefore, it is obvious how important the role of an engineer is on a project. Engineers may work within large architectural, engineering, AE firms, but most often they are independent consultants. Engineers' responsibility on projects is varied, depending upon their discipline, but in all cases, they must understand an owner's requirements, budget, operations, durability, and intended use of the space. All of these factors contribute to how an engineer chooses structural support, air conditioning, level of lighting and power, and plumbing capacity. Engineering tasks include specifying large equipment such as air handler units and electrical switchgear. Then the engineer must lay out the necessary distribution, ductwork, electrical conduit, and piping systems. They must also specify and locate termination devices such as radiation units, electrical outlets, and sink faucets. Because their work is detailed, communication within the design team is critical. Adjustments are ongoing in the design to accommodate the dimensional requirements of the building systems, and sometimes the work of an engineer can influence large shifts in the design approach. Engineers are regulated by professional licensing requirements that include a 4 or 5-year college degree, a specific number of years of experience, and the successful completion of 2 exams, one being the Fundamentals of Engineering or FE exams and, after proper documented experience, the PE or Professional Engineering exam. The PE exam is typically divided into 2 sessions, the breadth exam and the depth exam. As an example, the Mechanical Engineering exam is divided as follows. Basic Engineering Practice, the Mechanical Systems and Materials, HVAC and Refrigeration, Hydraulics and Fluid Systems, and Energy and Power. The depth exam would include principles, statistics and dynamics, and applications such as components, joints, and fasteners. Engineers, like architects, have many career options. The most common are found in the construction industry, and they include structural engineer, mechanical engineer, electrical engineer, civil engineer, and surveyors. As you can imagine, and as you have probably seen, architects and engineers have different skill sets, and therefore differing opinions when it comes to priorities on the job. The person responsible for bringing them together is usually the constructor. Let's now take a look at the construction professionals. The constructor is the individual responsible for all construction activities. Whether he or she works as a general contractor or as a construction manager. Of the 3 major participants on the project team, the constructor has changed the most in terms of type and training of personnel. In the past, company executives rose through the industry's ranks, often starting as carpenters or laborers. More recently, they may have entered the industry as degreed architects or engineers. Today, company heads also include graduates of business schools, construction management programs, or people with experience in the real estate or development industries. Their knowledge of the details of construction is supported by the expertise of specialty subcontractors. This trend is also working its way into the field management of jobs. Many project managers and superintendents have been trained in construction management programs, or they may be recruited directly from civil engineering programs. Such professionalization of the management of construction has allowed the industry to broaden the scope of services it can offer to owners. Estimators, purchasing agents, and schedulers. Those with not as much experience may also join the project as assistant PMs, or even as part of the labor force. Construction personnel are trained in a variety of ways. In the past, most started out in the trades and worked their way into management positions by either starting their own companies or joining others who had started their own companies. As projects became more complex and companies became larger, schools responded by offering degree programs in related fields. As an example, building construction or construction management. Supporting organizations also grew. Organizations such as the American Institute of Constructors, AIC, and the Construction Management Association of America, CMAA, now offer certifications. The AIC offers a 2-step certification with an initial exam right out of school, and after 4 years' experience, a second exam. The Certified Professional Constructor, or CPC, is a highly sought-after certification. This exam consists of 9 sections, which include project scope development, employment practices, working relationships, construction startup and support, resource management, cost control, project closeout, safety management, and ethics. The role we just covered is the GC, or construction manager. Now let's take a look at specialty contractors, or more generally known as subcontractors. These specialty contractors include mechanical, electrical, excavation, demolition, and a host of others. They are usually hired by and work directly for a general contractor. Specialty firms supply most of the materials and labor on a project. From the time the first pencil is laid to paper in the design process to the completion of shop drawings and coordination drawings, the goal is to instruct people who actually perform the work. These are the tradespeople. The number of trades needed on the job has grown with the complexity of the projects. Where once there were electricians, there are now also specialists in telecommunications and security. Where once there were plumbers, there are now also pipe fitters and sprinkler contractors. Most construction processes require specialized training. On complex building sites, as many as 15 different trades may be working on a given day. The opportunities in the construction trades are almost unlimited. The U.S. Department of Labor lists the following job categories for construction trades: boilermakers, brick mason, block mason, and stone mason, carpenters, carpet, floor, and tile installers and finishers, cement masons, concrete finishers, or segmental pavers, and terrazzo workers. Construction and building inspectors, construction equipment operators, construction laborers, drywall installers, ceiling tile installers, and tapers. Electricians, elevator installers and repairers, glazers, hazardous material removal workers, insulation workers, painters and paper hangers. And finally, well, you get the idea. To practice the craft is to create a legacy for generations to come, manipulating materials, assembling parts, creatively using knowledge and skill to create better conditions for people. These are all part of practicing a trade. At the end of the workday, an observer can see how those hours were spent. At the end of the job, there is something new for others to enjoy, sometimes for generations. Few jobs offer such tangible measures of success and enjoyment. A project may have talented designers, innovative constructors, and wealthy, sophisticated owners, but without materials to build with, the project would be only a drawing. Materials and building components are manufactured, fabricated, and installed by suppliers. A user's choice of material is based in part on performance, durability, and aesthetic appeal. But without the help of the suppliers and their trade associations, architects and engineers would be daunted by which materials to specify and constructors by which methods of material assembly to use. To promote their industry and provide information about material characteristics, suppliers have formed trade organizations that establish a level of quality for each product and standardize certain characteristics, as an example, dimensions or strength. The American Plywood Association is a trade association, as are the American Concrete Institute and the National Electrical Manufacturers Association. Manufacturers of materials that fall within their categories support these groups. Through research, the association developed criteria that members then agree to use. To ensure that the criteria have been followed, the associations provide oversight methods using seals of approval or some other mark as a stamp. Although they have no regulatory function, trade associations and their standards are often developed by other groups, such as the American National Standards Institute, A&SI. These standards are often incorporated into the architectural specifications, government regulations, and building codes. Depending on the project, equipment can play a very big role in construction. Highway jobs, large excavations, bridges, tunnels, and high-rises all rely heavily on the use of equipment to carry out the work. A major difference between equipment and material is the equipment does not become part of the project when complete. Equipment types break down into 6 loosely defined categories. Earth-moving, such as excavators, loaders, and trenching equipment. Lifting, cranes, aerial lifts, and boom trucks. Light equipment, items such as generators, pumps, and compressors. Bituminous machinery, planers, asphalt pavers, rollers, and soil stabilizers. Concrete and aggregate equipment. This includes crushers, mixers, pavers, and conveyors. and other components such as buckets, blades, and demolition tools. Behind all the people who interact directly with the construction is a host of other people who are involved deeply in the project. Before a project even starts, many issues must be resolved. Financing is certainly one of the biggest issues. Where the money comes from, how the funding is set up, and the terms and conditions of the funding all play a direct role in how the project will be managed. Many financial institutions are involved in funding construction companies, and some of the funding may come from government agencies as well. Certain public agencies are interested in the project from a regulatory perspective. They have the authority to rule on the conditions of the building and can deny the right to build if the project is deemed not in the public interest. These agencies include zoning boards, planning boards, historical commissions, and building code officials, all locally administrated and controlled. The roles of design and construction firms are certainly different, but because both participants are project-based, they have some similarities in the way they are organized. Both types of companies are internally organized to support technical people such as marketing managers, accountants, information systems, technical support, and human resource personnel. For instance, a marketing manager's position would be described in a similar way in both companies, varying only in details. A marketing manager's principal job is to generate business, establish the proper mix of work among the company's different specialties. He or she must understand the language and the process of the design and construction industry, translating technical language into lay terms. The position requires research, advertising, public relations, and client services. The person in this position is usually part of the upper management team that understands and contributes to the strategic business plan of the organization. At the project level, the profile of the company roles vary to some degree. Both design and construction companies hire outside help to complete a good portion of the work. For designers, this means consultants. For constructors, this means subcontractors or specialty contractors. To manage both in-house resources and outsourcing specialties, each firm, depending on the size and discipline, organizes its project teams a little differently. Here are some common staff positions in design firms. A project manager. As soon as the company agrees with the owner to perform the work, a project manager is formally assigned to the project. The project manager was probably introduced to the owner during the interviewing process, and in most cases the project is awarded with the understanding that this person will be assigned to the project. The project manager is the owner's primary contact, responsible for scheduling and housework and identifying necessary staffing levels for both in-house personnel and outside consultants. The project manager also helps the owner get bids from contractors and negotiate the construction contract. Sometimes the project manager is also the principal designer, the person with the ideas and the vision for turning the client's requirements into reality. Clerk of the works. This person is usually an architect or an engineer employed by the designer to enforce the terms of the contract and to interpret the plans and specifications. He or she may assist with problem solving, approval of project materials, approval or disapproval of methods and quality, and review contractor payment requisitions. Construction managers. Similar to the design firm's project manager, this is the first person assigned to a project. The primary responsibility of the construction manager is to configure the project team, schedule the job, and set up a cost control system. If there are any changes on the job, this person negotiates the costs with the various parties. The position requires many years of experience and solid knowledge of project administration, good verbal and written communication skills, knowledge of labor union issues, and technical construction knowledge is also required. Superintendents on the job site interact with specialty subcontractors, coordinating the flow of workers, suppliers, and equipment to ensure that the schedule is met. They also prioritize work and negotiate disputes between the trades. Because of their relationship with the subcontractors, Superintendents are usually the first to know about the problems on the job and are often in the best position to offer solutions. Traditionally, people in this position were from the trades themselves, working their way up to a management position. Recently, however, superintendents have been hired straight out of college, usually with engineering or construction management degrees. The field engineer is usually a young construction engineer who has graduated from a 4-year college program and takes this position as entry level. This person is typically assigned to handle the various documents that flow through the field office. He or she may also follow up on owner requests and communicate with tenants. An important function in the field, the job offers an overview of how a project is administered and constructed. A job captain organizes the drawings required to complete the project, manages the personnel resources, communicates with the engineers and/or project consultants. Organizationally and by way of responsibility, the position of job captain has changed tremendously over the past 100 years or so. This change has come because of the complexity of the projects being built, as well as managerial improvements, not just in this industry, but across the entire labor force. So let's finish this presentation by talking about great job captains. The Roebling family as a group can be credited with building the Brooklyn Bridge during the period of 1869 to 1883. It was the greatest project of its time and required the use of technology at a scale never before tried. The concept of a cable-supported suspension bridge was literally invented by John A. Roebling. Roebling was a man of tremendous energy and powerful intellect. He built a number of suspension bridges, most notably the John A. Roebling Bridge in Cincinnati, which is still in daily use today, that demonstrated the cable-supported concept prior to designing the Brooklyn Bridge. Upon his death, which was precipitated by an accident that occurred while surveying the Brooklyn Bridge location, his son Washington took charge of the project. Washington Roebling was a decorated hero of the Civil War who had received his training in civil engineering at Rensselaer Polytechnic Institute. Like his father, he was a man of great vision and courage. He refined the concepts of caisson construction and solved numerous problems as the great towers of the Brooklyn Bridge began to rise above New York City. Washington did not allow anyone to work under unsafe conditions. Therefore, he entered the caissons and supervised the work personally. He ultimately suffered a mysterious illness related to the fact that the work was carried out under elevated air pressure in the caissons. Today, that illness is called the bends, which was caused by the absorption and rapid exit of nitrogen from the bloodstream when workers entered and exited the pressurized caissons. This is the same illness that scuba divers have to be concerned with when diving. Although incapacitated, Washington continued to supervise the work from his apartment that overlooked the site. At this point, Emily Roebling, Washington's wife and the sister of an Army general, entered the picture. Emily carried information to the supervising engineers on the site. She became the surrogate chief engineer and gave directives in the name of her husband. She was able to gain confidence and respect of the entire construction team and was instrumental in completing the project. Another great accomplishment was the Panama Canal. The end of the 19th century was a time of visionaries who conceived of projects that would change the history of humankind. Since the time that Vasco Núñez de Balboa crossed Panama and discovered a great ocean, great planners had conceived the idea of a waterway or a link between the Atlantic and the Pacific Ocean. Having successfully connected the Mediterranean and the Red Sea at Suez in 1882, the French began work on a canal across the narrow Straits of Panama. After investing almost a decade into the project, the French were ultimately defeated by the formidable technical difficulties, as well as the hostile climate and the scourge of yellow fever. During this period, Theodore Roosevelt became President of the United States. His administration decided that the canal project must be completed. Using what would be referred to as gunboat diplomacy, Roosevelt precipitated a revolution that led to the formation of the Republic of Panama. Having clarified the political situation, Roosevelt then began to look for the right man to construct the canal. Roosevelt found his man in John F. Stevens, a railroad engineer who had made his reputation building the Great Northern Railroad. Stevens proved to be the right man at the right time. Stevens understood the organizational aspects of large projects. He immediately realized that the working conditions of the laborers had to be improved. He also understood that measures had to be taken to eradicate the fear of yellow fever. To address the first problem, he constructed large and functional camps for the workers, in which good, solid food was served. To deal with the yellow fever, he enlisted the help of an Army doctor named William C. Gorgas. Gorgas had previously worked with Dr. Walter Reed wiping out yellow fever in Havana, Cuba. Therefore, he understood to control yellow fever, you must eliminate the disease at its source. The source was the mosquito, and Gorgas proceeded to eliminate their breeding grounds and thus was able to control the yellow fever. Because of the high ground and low mountains of the interior portion of the area, it became apparent that the single elevation approach simply could not work. To solve this problem of moving ships over the hump of the interior, it was decided a set of water steps or locks would be needed to lift the ships up and over the high ground of central Panama. The construction of this system of locks presented an enormous challenge, particularly on the Atlantic side of the canal. The situation was complicated by the presence of the wild Chagres River, which flowed in torrents during the rainy season and dropped to a much lower elevation during the dry season. Stevens' qualities as a great engineer and leader were on a level with those of Roebling's. As an engineer, he understood planning must be done to provide a climate and environment for success. Based on his railroading experience, he knew a project of this magnitude could not be accomplished by committing resources in a piecemeal fashion. Stevens took the required time to organize and mass his forces. He also intuitively understood the problem of disease had to be confronted and conquered. Stevens was able to be decisive and was not held in check by committee or bureaucracy back in Washington. But then he did something no one expected. He resigned. Having set the course for what would ultimately lead to the successful completion of the Panama Canal, Stevens abruptly resigned. It was never quite clear as to why he decided not to carry the project through to completion. President Roosevelt did not take the resignation well and reacted by appointing a man that Roosevelt said could not resign, an Army colonel and West Point graduate named George Washington Goethals. Goethals had the managerial and organizational skills needed to push the job through to successful completion. Rightfully so, the general received a great deal of credit for the construction of the Panama Canal. However, primary credit for pulling the job out of the dumps and getting it on the right track and developing the technical concept to ultimately complete the project has to go to John F. Stevens. As you can see, the people in the construction industry cover a wide range of skills, experience, and expertise. From apprentice carpenters to company executives, the one thing that they share is that passion for the built environment. The building industry is tough, risks are high, working conditions are often harsh, conflicts arise because of financial pressures, and safety is always a concern. But when the right team is put together, challenges that seem insurmountable become surmountable, and the team can celebrate project success. And this concludes People on the Project, presented by Tech Training LLC.